A single whisper, a generated image, a predictive insight. These fleeting moments of artificial intelligence, so often taken for granted, harbor a secret. A hidden cost so immense, it could bankrupt an entire enterprise. We're talking about the electricity, the cooling, the sheer computational grunt needed, not just to train the world's most advanced AI, but simply to run it. For many, that price tag has become unsustainable. Today, in July 2026, AI isn't just a research curiosity. It's the engine driving everything from customer service chatbots to drug discovery. But the sheer operational expense of keeping these advanced models alive, particularly the inference phase for large language models and complex predictive analytics, is creating a critical bottleneck. Imagine a factory where every single product you make requires a million-dollar machine that runs continuously, even for the smallest task. That's the economic reality for many companies deploying advanced AI. The stakes are immense. If these costs aren't reined in, the widespread adoption of AI risks being choked by its own success. For years, the industry's answer to any computing challenge has been simple: add more power. More GPUs, more CPUs, more memory, bigger data centers. When AI models ballooned in complexity, the immediate instinct was to scale up the hardware, provisioning enormous, dedicated instances in the cloud. Most people assume that if an AI model is expensive to run, you just need a bigger, faster computer to make it more efficient. But that's where everyone is wrong. This brute force approach, while effective in providing raw computational muscle, is the digital equivalent of using a freight train to deliver a single letter across the country. It's overkill, it's inefficient, and it's draining budgets at an alarming rate because you're paying for capacity you often don't fully utilize. Imagine an entire symphony orchestra. If you wanted to hear a single flute melody, would you pay for every single musician, the entire brass section, all the strings, the percussion, to be on stage, warmed up, and ready to play, even if they remain silent? Of course not. This is precisely the inefficiency plaguing traditional AI deployments. The emerging solution, this new cloud service paradigm, doesn't throw more power at the problem. Instead, it breaks down the monolithic AI engine into a collection of highly specialized, independently manageable components, what we call microservices. Each microservice is like a single instrument in that orchestra, only engaged when its specific skill is needed. This architectural shift is crucial. Instead of running a single, massive AI model that consumes vast resources even when idle or only performing a minor task, cloud providers are now designing services where each specific AI function, say, a sentiment analysis module, a specific image recognition algorithm, or a text summarization component, operates as its own lightweight, independent microservice. This allows for incredibly granular resource allocation. You only pay for the exact flute melody you need precisely when you need it. The trade-off? This level of granularity introduces complexity in orchestration, coordinating dozens or hundreds of tiny services instead of one giant one. But innovative open APIs and sophisticated management layers are stepping in to handle that complexity, making this approach dramatically more cost-effective for end users. This fundamental change is reshaping the competitive landscape of cloud AI. The hidden incentive for cloud providers is clear: offer granular, highly optimized microservices, and you attract a broader range of customers, from lean startups to cost-conscious enterprises. The providers who master this orchestration, offering cloud AI services built on these principles, stand to capture significant market share. The differentiation isn't just about raw compute power anymore. It's about intelligent, flexible resource management. The old way meant significant vendor lock-in because migrating a monolithic AI model was a nightmare. But this new modularity, especially when combined with open API architectures, offers a path to greater flexibility, democratizing access and making it easier to switch or combine services without prohibitive switching costs. What does truly hyper-efficient AI mean for us? It means the dramatic reduction in operational costs isn't just a win for corporate bottom lines. It's a catalyst. Suddenly, advanced AI becomes accessible to smaller businesses, independent developers, and researchers who previously couldn't afford the exorbitant compute expenses. Imagine AI models designed for niche languages, highly specialized scientific problems, or even personalized learning assistants, all becoming economically viable. This isn't just about saving money. It's about unlocking innovation. It's about democratizing the most powerful technology of our age, allowing ideas that were once too expensive to even consider to finally flourish. We stand at the precipice of a new era for AI deployment. While the specific name of the one new cloud service might not yet be etched into history, the architectural foundation for dramatically cutting AI costs is being laid right now. Keep your eyes on services emphasizing microservice architectures, granular resource billing, and open, flexible APIs. These are the hallmarks of the true cost cutters. The era of wasteful, monolithic AI is slowly fading. The question isn't if AI will become universally affordable, but rather, who will build the ultimate engine of efficiency that takes us there, and what incredible innovations will follow. The hunt for hyper-efficient AI isn't over. It's just beginning.